Intro Quadratics, Projectile Motion, Lesson 1. Now we're going to apply what we learned about projectile motion and how it relates to the parabola with a quick problem with some data in it. A water bottle rocket is shot from the ground level at time equals 0. The rocket hits the ground approximately 8 seconds later. The rocket hits a max height of 70 feet. Sketch a graph that models the rocket's height in feet during its flight time in seconds. We'll start by making an x and a y axis. When we sketch this graph, we have two variables we need to think about. We have height and we have time. If we think about height going up and down, we can kind of come up with an idea that height would probably go on the y-axis. Time we'll put on the x-axis. Time is the independent variable in this case, and height is the dependent variable, meaning that the height depends on how much time has passed. We're going to go ahead and create 3 points on the graph. We'll do this by reading through the data again. A water bottle rocket is shot from ground level at time equals 0. If we think about a point being an x and a y, time is going to come first. We know that the time is 0, so I'm going to put 0 seconds, and the part that for the height at 0 seconds is the ground level, which is also 0. Another point that we can come up with, the rocket hits the ground approximately 8 seconds later. So the rocket is going to go up, it's going to come back down, and at a time of 8 seconds, which is our x, it's going to hit the ground, which is going to be 0 in height. The rocket hits a max height of 70 feet. In this case, we know 70 feet is the height, so I'm going to put that in the y. One problem we have right now is that I'm not sure what time it hits 70 feet. Let's go ahead and graph what we have. So along the x-axis, let's put time in seconds. And along the y-axis, let's put height in feet. And let's put a scale. We know that it's going to start at 0 seconds and go to 8 seconds. So I'm going to go and down here in the corner, put 0, 1, 2, 3, 4, 5, 6, 7, 8. And on the y-axis, I'm going to do the exact same thing, except we're going up to 70. I'm going to spread this one out just a little bit for some calculations later. I'm going to put 10, and I'm going to go by every 2. So 10, 20, 30, 40, 50, 60, 70. Okay? Let's go ahead and mark those points on there. We have 0, 0, which means we go 0 on the x, 0 on the y. We have 8, 0, which means we go 8 on the x, 0 on the y, so over to 8. Do not go up. And we have this one, which is 70. We know that the max is in the middle. So if we want to find what's in the middle between 0 and 8, well, it's obvious that the middle number between 0 and 8 should be 4. But if we want to calculate that, we can find the average. 0 plus 8 divided by 2. That's going to be 8 divided by 2, which is 4. And I'm going to put that with that point. So 470 over 4 up to 70, make a mark. In the activity prior to this, you learned that the graph of projectile motion is that of a parabola, and it has a nice curve to it. Kind of like a U, but in this case it's upside down, or what we call concave down. Now let's go ahead and answer some questions. And remember, these are all approximations. There are no calculations right now. How many times will the rocket be 40 feet in the air? Well, as we know, this rocket goes up and it also comes back down. So if it goes up from 0 and passes all the way up to 70, then it's going to pass 40 on the way up. But as it drops back down to the ground, it's also going to pass 40 in height. So it should pass 40 one time and then back down a second time. So how many times will the rocket be 40 feet in the air? We know that is twice. Approximate when. When we approximate when, that's all we're going to do, no calculations. We're going to go to 40 on the y-axis. We're going to draw a line across because this is where the rocket is at 40. You'll notice that there's an intersection here and an intersection there. Being that these are approximations, we don't have to be super exact. And all we're going to do is we're going to follow them and find the time. So when it hits 40, which is right here, we'll draw a line down. It looks like that's approximately 1.25. And in this case, when it hits 40, right here, that looks like it is approximately about 7. I know those aren't the exact answers, but we're just approximating off of the graph and figuring out how this works. So let's go to the next question. How many times will the rocket be 70 feet in the air? Well, if we follow the chart, we follow our graph, we start at 0, and we work all the way up to 70 feet, and then back down. Is there a chance for it to hit 70 twice in this case? No. We should only hit 70 once because it is the max, and the max only happens once. I'm going to put that right there. You can also see that if we were to draw a line across 70, it only comes in contact with that parabola right there the one time. Approximately when will the ball hit the maximum? Well, we've actually already come up with that. We know that when we average the two roots, or the 2 times it hits the ground, we said 0 plus 8 divided by 2, we got 4. We also know that that occurs in the middle of 0 and 8, which is also 4. So when, it will be 4 seconds. What is the y-intercept of the graph? This is when it comes in contact with the y-axis. To follow that, all we're going to do is we're going to start on the y-axis and we're going to go up and down it until we find out where it comes in contact. If you notice, it comes in contact right here at a y value of 0.